Welcome, everyone. Today, we are diving into the future of computing with VisionClaw, the era of situated AI. Imagine walking through a store, looking at a pair of headphones, and simply saying, "Add to cart," while your smart glasses and AI seamlessly execute an Amazon checkout in the background. We are finally integrating always-on egocentric perception with agentic task execution to bridge the gap between our physical context and our digital actions. To understand why this matters, let's look at the current disconnect in human-computer interaction, which we call the C versus ACT divide. Right now, we have powerful screen-bound AI agents that can execute multi-step tasks, but they operate with zero physical context. On the other hand, we have smart glasses that can see everything you see, but their capabilities are limited to passive Q&A. VisionClaw is the missing link, acting as a general-purpose situated agent that bridges real-world perception directly with autonomous task execution. So, how do we bridge these physical encounters with digital workflows? It happens in 3 phases. Phase 1 is continuous perception, where your wearable device, like Meta Ray-Ban glasses, constantly monitors your real-world context. Phase 2 is speech-driven intent routing via Gemini Live, where you can casually ask, "Can you check the reviews for this? If they look good, add it to my Amazon cart." Finally, Phase 3 is screenless multi-step task execution, handled seamlessly in the background by OpenClaw. This entire process operates on what we call the always-on architecture loop. To make this seamless, the glasses stream 16 kHz audio and 1 frame per second video, which preserves your context while saving bandwidth. This runs through a persistent WebSocket connection, entirely bypassing the need to pull out a phone screen. The AI processes this using native audio models for ultra-low latency, and then issues a tool call routed to our agentic execution engine. That execution engine is OpenClaw. It's essentially an ecosystem of autonomous subagents capable of managing your web browsing, emails, calendars, Slack messages, files, and even HomeKit devices. For example, if you look at a handwritten sticky note that says, "Turn on the light," OpenClaw will parse that ambiguous visual context and execute the precise digital API call to turn on your smart home lighting. To measure the impact of this system, we conducted a controlled lab study with 12 participants across 4 physical tasks. We isolated the variables of perception and action across 3 conditions: smart glasses that only offer visual context, phone agents that only offer task execution, and VisionClaw, which uniquely combines continuous voice and vision with autonomous task execution. The goal was to see if this combination truly creates a low-friction interaction. The results were remarkable. When looking at speed and success in situated action, VisionClaw was 13 to 37% faster than the baselines across tasks like note-taking, email composition, and product lookups. It achieved an impressive 85.4% success rate while drastically reducing the time spent on text-heavy tasks. Most importantly, it completely eliminated the manual execution tax, the frustrating need to switch contexts and pull out a phone screen to finish a visually initiated query. By eliminating that friction of translation, we drastically reduced users' cognitive load. NASA TLX analysis showed a 7 to 46% lower perceived difficulty. As one participant perfectly summarized, "I don't need to give all the information by talking to it. Because the AI already sees your world, the cognitive effort shifts seamlessly from the foreground to the background." But lab studies only tell part of the story. To see how this fits into daily routines, we conducted an autobiographical deployment study. 4 users wore the system in their everyday environments, logging over 550 voice-initiated interactions across nearly 26 hours of active use. We found that 39% of all interactions involved the glasses camera for visual grounding, proving that visual context is a massive driver of interaction when the friction of capture is removed. From this deployment, we identified a taxonomy of situated action consisting of 6 key categories. Users relied on the system to communicate via platforms like Slack, retrieve instructions for appliances, save meals to a digital food diary, recall past orders at a coffee shop, shop for physical products on Amazon, and control their physical environment by pointing at windows and lights. This usage highlights a fundamental shift from deliberate to opportunistic capture. The old paradigm required you to stop, pull out your phone, open an app, snap a photo, and manually tag it. The new paradigm is a reflexive, opportunistic byproduct of simply looking at something and speaking. If you look at a hotel welcome sheet, the agent automatically extracts the Wi-Fi password and breakfast hours, structuring and storing the data without you lifting a finger. However, this introduces what we call the calm but cautious reality of screenless delegation. On one hand, it's deeply calm. You can chop vegetables while your agent categorizes and archives your unread emails in the background. But there is a paradox. The absence of visual feedback creates a tension and an expectation gap. Users trust the ambient system for low-stakes automation but still want a manual screen check for critical tasks, highlighting a challenge in building ambient trust. Based on all of this, we've defined the 4 new rules of human-AI interaction. First, we are moving from single-turn voice commands to open-ended chaining, allowing for multi-step conversational research. Second, information capture is shifting from a deliberate action to continuous, opportunistic capture. Third, task execution is moving from visual screens to calm, cognitive background execution. And fourth, these tools are evolving from static utilities to an evolving personal memory. That fourth rule leads perfectly into the value evolution curve of personal agents. In the early days of use, interactions are flat and stateless, like asking for the weather. But once the system hits a memory accumulation trigger, its value skyrockets. The usefulness of an always-on agent is not fixed at installation, it exhibits a data network effect, progressively expanding and handling complex, cross-app workflows as its memory logs grow. Looking ahead, we are designing for the ambient horizon based on 3 pillars. First is proactivity, moving from reactive commands to agents that offer silent, background nudges based on what they see. Second is solving the total recall dilemma, transitioning from data hoarding to intelligent memory curation. And third is ambient feedback, integrating subtle AR visuals to bridge the trust gap of screenless execution. Ultimately, we are transitioning from tools we use to agents that live situated alongside us. Thank you.